Welcome to this deep dive. This is where we take the sources you suggest and, well, really dig into them to pull out the most interesting bits.
Uh-huh.
And today we're tackling something absolutely fundamental to, well, pretty much everything digital. It's something you use constantly, probably without even thinking about it. We're talking about SQL.
That's right. And we got some great source material to work with here. Author profiles for folks like Charles Delalanne, Donald Chamberlin, Raymond Boyce.
Right there, Wikipedia pages too.
Yeah, and the abstract from that original SQL paper, plus the SQL Wikipedia page itself. So our goal today is really to trace the history, how SQL came about, and then look at the massive impact it's had.
It really is kind of invisible, isn't it? Databases are just everywhere. Online shopping, social media, finance.
Everything.
And SQL is often the language making it all work behind the scenes. So the big question is, how did this foundational piece of tech actually come to be? Let's unpack that.
Okay, well, the story really starts, you can argue, with Edgar F. Codd. His 1970 paper on the relational data model. That was the game changer.
Before that, it was different, right? More like trees or networks.
Exactly. Hierarchical or network models. Think family trees or complicated webs. Codd came along and said, let's use tables. Simple rows and columns.
Much more intuitive, sounds like.
It was a fundamental shift. Instead of following fixed paths, you could look at relationships between tables. And that flexibility, that's what paved the way for SQL. Both Chamberlin and Boyce pointed directly to Codd's work as their inspiration.
Okay, so Codd sets the stage. Then we have the people who built on it. Let's talk about Donald Chamberlin first. From San Jose, California, studied engineering at Harvey Mudd, then Stanford for his master's and PhD in electrical engineering. But crucially, he picked up a computer science minor there too.
Right, that combination seems important.
And he did a summer internship at IBM Research.
In Yorktown Heights.
Yeah, which led to him joining IBM full-time after his PhD. He ended up back on the West Coast later at IBM's Almaden Research Center. And now he's a technical advisor at Couchbase. Quite a career, really linking that academic background with practical application.
It really highlights how innovation often happens at that intersection, doesn't it? Taking theory and making it work in the real world. Now, Raymond Boyce, a slightly different path, but also ending up at IBM.
Born in New York City, went to Providence College, then got his PhD in computer science from Purdue in '72.
And like Chamberlin, he joined IBM right after, also starting in Yorktown Heights, working on database projects.
Then he moved out to San Jose, where he actually managed the relational database development group. So they both ended up in the same place around the same time.
It seems like that San Jose lab in the early 70s was a real hub.
Definitely. And the sources mention something quite personal about Boyce. His wife, Sandy, and their baby daughter, Kristen.
Yeah, it adds a human touch. But also, tragically, he passed away very young.
Only 27. An aneurysm in June 1974. It's
quite sad. It really is. A reminder of the people behind the tech. But in that relatively short time they worked together at the San Jose lab, Chamberlin and Boyce formed this really effective partnership.
And they brought different strengths to the table, right?
Yeah.
Chamberlin was more the programming languages guy.
Exactly. Programming languages, compiler theory. Boyce, on the other hand, was the database system specialist.
So they had this perfect combination of skills. What was the specific problem they were trying to solve then?
Well, they were working on IBM's System R project. The goal there was to build a working relational database system based on Codd's ideas.
Okay.
And they realized, Codd's model is great, but you need a way for people, not just database theorists, to actually use it, to ask questions, get data out.
They needed a user-friendly query language.
Precisely. Something easier than the formal mathematical stuff, something more accessible.
Which brings us to the language itself. It wasn't always called SQL, was it?
No, their first go was called Square, specifying queries as relational expressions.
Catchy acronym.
Maybe. But the notation. It used subscripts and superscripts. Apparently, it was just too difficult for people to use easily.
Right. Not very user-friendly if you need special characters all the time.
Exactly. So they rethought it, and they came up with SQL-structured English query language.
SQL. Okay, that sounds more promising.
And there was a bit of a clever pun in there, too, supposedly a nod to QEEL, which was the language being developed for the Ingress system over at Berkeley. A little academic rivalry, perhaps.
Love that. So SQL it was. But wait, we call it SQL now. What happened?
Yes. The classic trademark issue. Turns out a British engineering company, Hawker Siddeley, already had a trademark on the name SQL.
Oh, lawyers got involved.
Seems like it. So to avoid trouble, they just dropped the vowels. SQL became SQL.
Just like that, SQL.
Just like that. And funny enough, even though it started as just an abbreviation, people later kind of retrofitted an acronym onto it. Structured Query Language.
Which is what most people know it as today. And they documented all this in a 1974 paper, right? SQL, a structured English query language.
That's the one. It really laid out their refinements over Square, focusing mainly on how to retrieve data.
What were the big ideas in that paper? What made it so different?
Well, the abstract itself gives some good clues. It talks about letting users work with data in tables using, and this is key, a simple, intuitive syntax. No need for complex math like bound variables or quantifiers that other systems needed.
So hiding the complexity.
Exactly.
Yeah.
They came up with what they called consistent set of keyword English templates. Think select, from, where the words we still use constantly.
The core building blocks.
Right. The idea was these simple templates mirrored how people naturally think about getting information from tables. And crucially, you could compose them, link them together to ask really complex questions. It was meant for programmers, sure, but also for people who weren't database experts.
That accessibility seems like the key factor. So let's talk about the impact. Why was SQL so revolutionary?
Well, several reasons. First, as we said, that simple English-like syntax, select where from. It just drastically lowered the barrier to entry for working with databases. The paper really hammers home that user-friendly aspect.
Made it less intimidating.
Definitely. Second, it was the practical implementation of Codd's theoretical ideas. It took relational algebra and calculus concepts and put them into a form programmers could actually use. The abstract even mentions it had the power of something called first-order predicate calculus.
Sounds complicated.
It is. But SQL managed to provide that power without forcing users to understand all the underlying formal logic. It abstracted away the complexity.
And the third big thing, which the sources really stress, is that it became the first commercially successful standard language for relational databases.
Huge. Absolutely huge. Standardization was maybe the killer app, in a way. SQL didn't just work. It became pretty much every major relational database system that came along adopted it. IBM's own DB2, Oracle, Microsoft SQL Server, MySQL, Postgres, the list goes on.
So learning SQL meant you could work with almost any major database.
Exactly. That portability of skills was massive for developers and companies. You invest in learning SQL, and that knowledge is valuable across the board. It just fueled the growth of relational databases like crazy.
And it's still true today, right? Even with cloud databases.
Oh, yeah. Look at Amazon Redshift, Google BigQuery, Snowflake.
Yeah.
They're all built around SQL compatibility. It's still the lingua franca of data.
And this wasn't just an informal thing. It became official.
Yep. ANSI, the American National Standards Institute, made it a standard in '86, SQL '86. Then ISO, the international body, followed suit in '87.
So formal recognition.
Right. And those standards have been updated over the years, adding more features, keeping it relevant. It really cemented SQL's place.
It's kind of mind-blowing, really. A language designed in the early 70s is still so central to, well, everything data-related today.
It really speaks volumes about the quality of that initial design by Chamberlin and Boyce. Its core ideas were just so solid.
The impact is just undeniable.
Totally. Think about business intelligence, data analytics, data science as we know it. None of that would likely exist in the same way without SQL making it possible for analysts, marketers, engineers, whoever, to actually query data effectively.
It democratized data access in a way.
That's a good way to put it. Even now, almost 50 years later, knowing SQL is still a fundamental skill in data management. It's endured.
And we should remember the people. Chamberlin went on to have a long career, even worked on XML query languages later.
Like XQuery, yeah. Continued contributing.
And Boyce, despite his tragically short life, his contribution through SQL, it's just immense. His work lives on in virtually every database-driven piece of technology we use.
Absolutely. Their collaboration, brief as it was, genuinely changed the world.
Okay, so wrapping up this deep dive, we've gone from Codd's theoretical breakthrough with the relational model
to Chamberlin and Boyce taking that theory at IBM and turning it into SQL, this practical, powerful, and crucially accessible language.
We've seen how its English-like structure and its eventual standardization made it the universal language for relational databases.
And how that transformed, well, pretty much everything about how we manage and use data in our modern world.
It really makes you stop and think, doesn't it? Imagine a world without SQL, without that common way to talk to databases. How different would technology, business, science How different would it all look?
It's hard to even picture.
Makes you wonder what other foundational technologies had these kinds of, unexpected origins and massive impacts. Something to ponder, maybe the invisible layers of tech that run everything. Anyway, thanks for joining us on this deep dive.